Welcome to the opening session in the fourth part of the Humanities Center's sixth semester exploration of natural landscapes and human meaning. As those of you who have attended these sessions before will know, this initiative constitutes an attempt to consider dramatically different landscapes from a wide array of perspectives spanning the gamut of academic disciplines, from the arts and humanities to the sciences. And we've now investigated three very different landscapes: the ocean, the desert, and the forest. And we turn our attention now to something very different again, what we've called the frozen realms, the world of the poles, of glaciers, ice fields, and snowy terrains. And the Humanities Center's programming this semester is positively overflowing with this icy theme. In this series, in addition to our regular panel discussions, we have a special lecture by the art historian Christopher Hoyer, who's the author of a remarkable study of the Renaissance Arctic. We have a special class on this subject offered to our students and taught by Fred Robinson. Thanks, Fred. And the exhibitions in our gallery focus on this topic too. Indeed, for the first time, we will have not two, but three exhibitions on display. The first of these, after icebergs, conceptual photography and climate crisis, features the photographs of Mark Dion and our very own Farah Karapetian. That can be viewed today. It will be open until the end of the session today. And then later on in the semester, we'll feature the time-based work of Joan Perlman. And finally, in May, we will screen Braden King and Laura Moyer's remarkable documentary about the Aleutian Islands, Dutch Harbour, where the sea breaks its back. Now, the details of this semester's programming on the Frozen Realms can be found in the spring calendar, which you should all have. And its front cover is this wonderful photograph by a USD student, Bryson Patterson, who will be speaking in this series. A few words of thanks are in order. The exhibitions this semester have been beautifully put together by Sarah Bain, Susie Smith, and Derek Cartwright. So thanks to the three of you really heartily. For their advice and organisational skill, thanks are due to Maggie McRae and, of course, to the incomparable Lindy Veer, whose work here is just unfathomably extraordinary. And our work in the Humanities Centre, as ever, would not be possible without the support and vision of the college's fantastic Dean, Noel Norton. In this series on Tuesdays, there will be 20 speakers who will be contributing. I'm grateful to each of them for the time and thoughts that they will dedicate to our reflections this semester. And of those 20, I also want to express a special thanks to today's principal speaker, Ron Kaufmann, who is joining me up here for this opening session. I'll just say a few words about Ron before offering some preliminary reflections on this semester's theme. So, Ron Kaufmann is Professor of Environmental and Ocean Sciences here at USD and is also Associate Dean for Programs and Curriculum in the College of Arts and Sciences. He received his PhD from UCSD's Scripps Institution of Oceanography and specializes in environmental biology with an emphasis on the study of marine life in extreme environments, such as the Antarctic and the deep ocean. Another of Dr. Kaufmann's specialisms is the study of orchids, and he is the co-author of the book, Orchids of Tropical America. In this context, Ron's work for the Humanities Center is also absolutely invaluable. A member of the three-person steering committee, he oversees the interdisciplinary curriculum element of our programming and has done this with his characteristic diligence, vision, and attention to detail. Thank you, Ron, you're the best. I want us to think just a little about one of the themes that has bubbled up time and again during the prior semesters of our exploration into landscape and meaning. And this is the theme of how human aspirations and human self-confidence run up against the implacable, inscrutable forces of natural terrains indifferent to our goals and our happiness. We saw this, of course, in relation to the raging power of the ocean, the blistering aridity of the desert, and last semester, the mysterious darkness of the forest, with which civilization has fought a centuries-long battle. Now, we can note a number of ways in which this contrast manifests itself. Here's one. In Turgenev's great novel, Home of the Gentry, for example, the domestic drama of this novel plays out against the vast silence of the Russian countryside, indicating in some manner the ephemeral quality of human troubles. And this becomes explicit when the central character in the novel, Lavretsky, returns to his old family home after many years and after his marriage has fallen apart. Lavretsky is struck by how overgrown with thick weeds the garden has become. And we find these words. Traces of human life vanish very quickly. Glafira Petrovna's estate had not yet gone wild, but it seemed already to have sunk into that quiet repose which possesses everything on earth, wherever there is no restless human infection to affect it. Something like human infection is an important idea. Now, of course, human grandiosity will rebel against such a demeaning suggestion as this. We think of our achievements as somehow superior to all that brute nature does. And reminders of our vulnerability are often felt as an affront. Hence, as another example of this, we can note the typical reader's disquiet when confronted by Nietzsche's words. This is Friedrich Nietzsche at the end of his life with a truly heroic moustache. These are the words that Nietzsche puts at the beginning of a very memorable essay called On Truth and Lies in a Non-Moral Sense. That's how the essay begins. In some remote corner of the sprawling universe, twinkling among the countless solar systems, there was once a star on which some clever animals invented knowledge. It was the most arrogant, most mendacious minute in world history. But it was only a minute. After nature caught its breath a little, the star froze and the clever animals had to die. This is an extraordinary image of human endeavor. And those words, arrogance and mendacity, are worth pausing over. And I think they may be pertinent to this landscape theme. So a quick thought, first of all, about landscape and mendacity. For example, when we enter the desert, some of us may gain a sense of this forbidding terrain standing there in great and honest silence, as against the endless babble and frequent dishonesty of human voices. You know, oddly, this very contention, I tend not to talk about such things as this, but this contention presented itself to me when I was looking through the other day my old record collection. And I came across an album from the 1990s by a great and neglected American band called Père Ubu. This is the cover of the album. I'm not going to read through, I'm going to play it at all. I'm not going to read through this very lengthy lyric either. You're more than welcome to come and look at it at some point. But they're rather striking lyrics, operating on a distinction between lies and the land. So you have these words, liars own the words. The productions of culture exhibit mendacity. And in that great line, history is rewritten faster than it can happen, which I like a lot. On the other hand, the land cannot lie. And then as for geography, you have this great line. I've never heard in a rock song before. Geography is a language they can't screw up. Now, I don't want to push this too far, because this song lyric is not intended as an academic treatise, but those ideas evoke something. It is revivifying, perhaps, in the face of the onslaught of lies and misrepresentations that seem to engulf us these days, to step away from all of that, even if just for a moment, and be immersed in a landscape that isn't trying to argue with us, isn't trying to convince us of something, isn't trying to pretend to be something that it isn't, but rather is just there in its naked reality. Now, nature's antidote to human arrogance, in addition to mendacity, is easier to see and easier to detect. And I can think of no better visualization of this than Edwin Landseer's deeply unsettling painting from 1864, Man Proposes, God Disposes. This is a big canvas. It's 6 feet by 3 feet, and it's in the collection of Royal Holloway, University of London. Greatest university in the world, I might say. What we are confronted with here, of course, is a scene of human wreckage, of the remains of what was once a bold and confident expedition into the treacherous terrain of the Arctic. Polar bears, 2 of them, pick over the scattered fragments of a ship. There is a naval flag, a sail, a telescope in the far left corner, and a human rib cage here and part of it here. This is a bleak and when I said she was writing this thing, I didn't realize how bleak it was going to be. You're going to need a drink. Well, fortunately, as I say, this is a pretty grisly scene, leaving us with an impression of the vulnerability of human effort in the face of the far superior forces of a hostile nature. Note also the title of this painting, which is a really great title, Man Proposes, God Disposes. This is drawn from Thomas à Kempis's devotional classic, The Imitation of Christ. It's drawn from a passage in which human resolution is seen to depend more upon God than upon our own wisdom and fortitude, and in which it's held, and I quote, man's destiny is not in his own hands. In other words, man may propose, but God disposes. In the context of Landseer's painting, the words constitute a warning against exaggerated arrogance and hubris. A couple of other things about this painting I'd like to note. One of them is fairly frivolous and the other one isn't. At Royal Holloway in London, it hangs in a hall where students take their final exams. And a number of superstitions have grown up around this painting in this particular setting. Students believing, apparently, that the painting is cursed or haunted. Since the 1920s, the tradition has been that anyone whose exam desk was positioned in front of it would fail the exam. And thus, a college tradition now dictates that Landseer's painting should be covered, usually by the Union Jack, God bless it, whenever student examinations are taking place. Now, something here again you see about the fragility of human endeavour. It's not, taking an exam is not quite, and I break this to my student friends, it's not quite as difficult as getting into the Arctic Circle. But it's still something that can bomb very badly and result in unpleasantness. A second thing, Landseer's painting depicts not just an imagined expedition, but a very specific and notorious one. The Arctic expedition led by Sir John Franklin, an expedition which left England in 1845 and met with disaster when both ships, the HMS Erebus and, take note, the HMS Terror, again, I still find the name of that ship extraordinary. Both these ships became icebound in Victoria Strait. All 129 men died as a result, probably, of a combination of hypothermia, scurvy, starvation, and lead poisoning due to corruptions in the canned food they had brought with them. And this expedition, the Lost Franklin expedition of 1845, has captivated the imagination of a great many people in the years since its disappearance. The idea of ships being immured in ice, slowly crushed by the pressure, is deeply redolent of the productions of romantic art, most obviously, of course, Caspar David Friedrich's famous The Sea of Ice, a painting suffused with the component notions of the Burkean sublime. I'm not going to say much more about the sublime here because we've covered this ad nauseum for semester after semester. But you get the vast and astonishing force of a natural power far superior to the human, something in the face of which we feel small and vulnerable. And you see, of course, the broken ship being crushed by the ice here, tiny in relation to this natural power. And of course, with regard to Franklin again, the mysterious end of the expedition gives us a blank canvas on which every nightmare and every horror can be painted freely. Unnerving worries about what human beings will do to each other in extreme circumstances populate these nightmares. And the allure of some supernatural agency also arises here. And that idea is central to Dan Simmons' fantastical treatment of the Franklin expedition in his novel, inevitably called, how could it not be, The Terror. And that novel, I mean, some of you presumably have seen this. It was adapted very successfully for, very good nodding head, very successful adaptation for television, again, simply called The Terror. And the aesthetic of that TV series very much draws from the Sea of Ice model. This is a still from it. It is a claustrophobic, horrifying series. The Terror, of course, is not alone in using the context of a frozen world to evoke a sense of fear and horror. The classic, of course, and probably, possibly founding example of this is Mary Shelley's Frankenstein. As an aside, And speaking as director of a Humanities Center, I should say, I really think that this is a book which everyone, if you're not already familiar with Frankenstein, as you should be, but this is the great book about scientific enthusiasm and moral responsibility and moral irresponsibility. Really, we talk about the kind of books we should be reading when to approach, AI. This really is the thing that might help us, prepare for AI and the next set of horrors that the world's restless innovators will inevitably unleash upon us in the near future. So Frankenstein is the great text. Anyway, any of you familiar with Frankenstein will remember how the narrative is bookended by scenes of the frozen realm of the north, how many references there are to a sea of ice, and how that awful idea of ice immuring a ship appears in the book. And this is a letter in the book. My beloved sister, I write to you, encompassed by peril, and ignorant whether I'm ever doomed to see again dear England and the dearer friends that inhabit it. I am surrounded by mountains of ice. Wonderful expression. Mountains of ice, which admit of no escape and threaten every moment to crush my vessel. Again, you have this sea of ice idea at work here. Now, whether or not influenced by Frankenstein's icy framing, the action of countless other works of horror or supernatural fiction is set among the frozen world. We might name here Michel Paver's very disturbing book, Dark Matter, in which a solitary radio operator at a research station on an otherwise uninhabited Norwegian island realizes that he is not in fact alone and has to battle both against the polar darkness and against a malevolent spectral presence. I'm also struck by a remarkable short story, The Haunted Blizzard, by the Inuk writer Aviak Johnston, and featured in an interesting collection of Arctic horror stories, Taktumi, word meaning in the dark. In The Haunted Blizzard, a schoolgirl ignores some shouted advice about an approaching blizzard, and the shout is, the storm is full of bad things. She ignores that, and well, I won't say any more about it. It's a really interesting, disturbing, frightening short story. You can also add to how cold and snow adds to the chilling of, well, you can note that word chilling. It's interesting that we watch a horror movie, we feel it's a chilling movie. It's interesting that we use that word. So cold and snow adds to this chilling effect of really good horror movies. Preeminently, you think about Stanley Kubrick's The Shining, but also The Thing, 30 Days of Night. The list goes on here. Why does this work so well? Maybe because of what I mentioned just now, how the shocking low temperature of a frozen realm mirrors the chilled sensation we experience when we are scared. Maybe it puts us in mind of the coldness of the grave. Or maybe, really to emphasize the natural landscape theme, the frozen realms are of all places the most inhospitable to human beings. The most inhospitable. And accordingly, perhaps, the most able to produce a profound sense of fear. I take that idea from a fascinating piece written by Yi-Fu Tuan, the late geographer, who, as many of you will know, has been a very big influence on our programming in this series. There's a very interesting essay by Tuan called Desert and Ice, Ambivalent Aesthetics. And in this piece, he is exploring the affinities between these two harsh environments, one of which, of course, the desert was the focus of our investigation this time last year. Now, both of these terrains, he writes, have produced ambivalent responses in humans. They are often neglected. But they have produced in others, in explorers, researchers, artists, a fascinated and entranced engagement, what he calls worshipful admiration tinged by fear. I love that phrase, worshipful admiration tinged by fear. And in his discussion, he notes that the world of ice is even more hostile and certainly more barren than the desert. Twan says the great ice flows and inland plateaus are implacably hostile to human life. They are the great empty spaces. And yet, they hold their own allure. And for an appreciation of this, Twan asks us to consider the explorers of the poles, those romantic figures who push themselves to the limit. We may call to mind here Scott, Shackleton, or Lawrence Oates. Oates, whose great act of self-sacrifice when walking away from Scott's tent into a minus 40 degrees blizzard is famous for its gorgeous understatement, the most gorgeously understated last lines of any person's life. As you all know, I'm just going outside, and I may be some time. This remarkable, heroic, understated end is the subject of John Charles Dolman's painting, A Very Gallant Gentleman. So here you have the Scott tent in the background, and Oates disappearing off into his blizzardy death. So many reproductions of this, different versions of it, put in schoolboys' annuals and things to produce a sense of the kind of person to be. Now, to explain the allure of the ice, however, Twan's favoured explorers are Fridtjof Nansen and Richard Byrd, both of whom wrote memorable books about their experiences in these extreme environments. Nansen's book, Farthest North, and Byrd's book, Alone. Both books, Twan believes, capture what he calls the longing to be taken out of oneself and one's habitual world into something vast, overpowering, and indifferent. The writings of Nansen, in particular, he thinks, present to us the austere beauty of a world unhandselled, untouched, and silent. And I will close my part before going over to Ron with what the words that Twan quotes from Nansen from Farthest North. Beautiful book, actually. Unseen and untrodden under the spotless mantle of ice, the rigid polar regions slept the profound sleep of death from the earliest dawn of time. Years come and go unnoticed in this world of ice. In this silent nature, no events ever happen. There is nothing in view save the twinkling stars, immeasurably far away in the freezing night. A weird beauty, without feeling, as though of a dead planet built of shining white marble, and everything so still, so awfully still, with the silence that shall one day reign when the earth again becomes desolate and empty. With those, I find those words uplifting, actually. It's been a long day. And now, it's my great pleasure to introduce a dear friend and a wonderful colleague in the College of Arts and Sciences, Dr. Ron Kaufmann.
That was lovely, Brian. Thank you. Okay, well, thank you very much. As always, I appreciate the invitation to speak. I appreciate the invitation to share an event with Brian. I dread having to follow him because my eloquence is sorely lacking in comparison to his. But what I want to try to do, a little bit less poetical, is talk a little bit about what a natural scientist might think of as the frozen realms. And I have to say, I've had some time, so for those of you who don't know, some of my research has involved travel to the Antarctic. There are a couple people in this room who've been there on expeditions with me. And there are plenty of opportunities when you're there to reflect because the atmosphere is very similar to the way Brian articulated, when others have articulated it. But what I want to try to do today is sort of circumscribe the frozen realms a little bit from the standpoint of what all that really is, or what all that potentially could be. Full disclosure, I grew up in Minnesota. And so this is my undergraduate alma mater at about this time of year. As they said to Indiana Jones, and I think Indiana Jones and the Last Crusade, you have chosen wisely. So obviously USD doesn't look like this time of year, and Brian, you can ignore the banners. I apologize for that. The University of Chicago went one better. This is the University of Chicago, about the same time of year. And when I was a graduate student, I had a friend, one of Sue Lowry's lab mates, who had been to the University of Chicago as an undergraduate. They won up the University of Minnesota by producing these T-shirts. So, on that lovely note, let me talk a little bit about what exactly the frozen realms are to somebody who's a little more immersed in the natural sciences. People sometimes break the Earth down conceptually into 5 spheres. So we have the lithosphere, which is the solid Earth, the geological portion of the Earth, the hydrosphere, the liquid water, the atmosphere, the air, everything from ground level essentially up to outer space, the biosphere, the living organisms that inhabit the Earth, and then the cryosphere. And cryo is a prefix that means cold. So these are the cold realms. They're not necessarily frozen, but they are cold. And the cryosphere includes a number of different elements. So this is a conceptual vision of essentially what the different types of cryospheric elements are. I will talk a little bit about each of these individually, but this is a general overview. So we have things like glaciers, which are accumulations of ice, typically in between geological formations, mountains and what have you. When glaciers get thick enough, they may actually become ice caps, so they actually overtop the land, so you can no longer see the land. There's seasonal ice that forms on lakes and rivers. I won't talk about that too much. There's permafrost. Permafrost is permanently frozen soils. And there are some soils that are permanently frozen year-round, and there are others that thaw during the summer and then refreeze during the winter. People who live in places where there's permafrost can actually use the ground as a cold storage facility during the winter. They're going to the other side, you have ice sheets. An ice sheet is just essentially a gigantic glacier. And the Earth currently has 2 major ice sheets that I'll talk about. Of course, there's snow that falls on all of these things, and snow is responsible for the formation of ice sheets and glaciers and ice caps. When ice sheets flow down to the ocean and a portion extends out over the liquid ocean, those are called ice shelves. And then in the ocean, you have sea ice. And I keep forgetting, the pointer doesn't work on this thing because it scatters the red light. So sea ice, some of which is in place year-round, and others of which forms during the winter, melts off during the summer. So I'm going to not talk in depth about each one of these individually, but I wanted to give a bit of an overview of what the different elements of the frozen realm or of the cryosphere might be. This is a somewhat disorienting representation, but let me explain why I showed you this instead of one that has the northern hemisphere on the top and the southern hemisphere on the bottom. If you think about it for a second, some of the permanently frozen portions of the Earth are at the northern and southern limits of the globe, right? And if you show a sort of a traditional Mercator projection of a map, you have very, very little up in the north and very, very little down in the south, and it misrepresents how much ice there is. So this is a better representation of that. It also does a better job of representing relative sizes of things. So here we have the 2 major ice sheets. You have Antarctica right here and Greenland here in the north. Very, very little in the way of ice or snow in South America, except when you start to get to the southern tip here. Everything essentially from here on south is a series of valleys filled with ice, filled with glaciers. There is a lot of permanent ice up here in the northern part of North America and the northern part of Eurasia. You've got glaciers in a variety of different places, including, interestingly enough, a glacier right here in what would otherwise appear to be tropical Africa. Anybody know what that glacier is? Mount Kilimanjaro. That glacier is shrinking, and I'll talk a little bit about that later. So there are glaciers in a number of different locations. Permafrost, I won't actually say too much about. So collectively, these are what we might consider to be the frozen realms. So a few frozen facts, and then I'll dive in a little bit into the specific systems. So permanent ice, permanent snow covers around 10% of the land area of the Earth. It's permanently frozen. Ice caps and glaciers collectively hold a little over 2/3 of the world's fresh water, and if all of this were to melt, and we hope it doesn't do that anytime soon, sea level would rise by about 70 meters, or about 230 feet. That's how much water is bound up in all of this ice. If you own beachfront property, and you're taking a very, very long view of things, you might be in trouble, but in the short term, you're probably okay. The Antarctic ice sheet, which is the larger of the two big ice sheets, is 5.4 million square miles. That's about the same size as the contiguous United States and Mexico. And at its thickest is up to 2 miles thick. And later in the semester, I'll be talking a little bit along with a couple of other people about polar exploration. And I'll talk, among other things, about efforts to go across the Antarctic continent. That's not just walking this way. That's walking 2 miles up and then back down to get to the other side. It's fascinating to contemplate and daunting, to say the least. The Greenland ice sheet is about 656,000 square miles. That's about 3 times the size of Texas. And that's the smaller of the two ice sheets. And the largest iceberg in the world, which I'll say a little bit more about later, as of a couple months ago, had an estimated mass of 1 trillion tons. I have a hard time conceptualizing that, so I was trying to do a little bit of arithmetic just to kind of put it in a form that I could understand a little better. And what I estimated is that if you melted the whole thing, which seems to be ongoing at the moment, by the way, it would produce 240 trillion gallons of water. That is enough to support all of the household use in the United States for 18 years. That's one iceberg. So the amount of the volume that we're talking about, the extent of all of this is just truly astonishing. Let me talk a little bit about the various systems. So we start always with snow and ice. If it weren't for snow, we wouldn't have ice, honestly, except for some of the ice that forms on lakes and rivers and so forth. In general, 1 foot of snow is about equivalent to 1 inch of rain. So if you've ever been in a place where there's a blizzard and they say, well, we got 3 feet of snow, that's pretty substantial, but it's only because snow packs fairly loosely. It's about 90% air, and most of the rest of it, so it's actually very, very airy. It's not very firm. Snow, and you've all seen snowflakes before, snowflakes look kind of like this, but once they've fallen, unless they melt off, they actually melt a little bit, refreeze, melt a little bit, refreeze, and they form this other sort of quasi-snowy, not quite ice substance called firn, that I'm probably mispronouncing, but my Swedish and Norwegian are a little bit weak. So it goes through a series of melt and freeze cycles, and eventually forms ice. And as it forms ice, these spaces get less and less, and I apologize if some of you are blocked from seeing this, but in the lower right, this is actually a slice through a piece of ice. And I want you to notice a few things. First of all, it doesn't really have that beautiful crystalline formation that snow has. It gets compressed so it becomes denser, still not as dense as water, which is why it floats. It's a good thing. But it also has gas bubbles and inclusions like this, and that makes it very useful for some scientists who are interested in using the contents of those gas bubbles to help get information about past climate on the planet. Snow and ice have a lot of value from a purely functional standpoint. Aesthetically, of course, they're lovely, but from a functional standpoint, they contribute very importantly to the Earth's albedo, which is essentially another term for reflectivity. So the Earth in general, solar radiation comes in, and clouds reflect solar radiation back. Almost everything on Earth reflects solar radiation back, but the darker something is, the less radiation gets reflected back. Snow and ice are very, very good reflectors. So when you have a large portion of the Earth covered by snow and ice, it means that that part of the Earth is very reflective. Anything that isn't reflected generally gets absorbed. And one of the positive feedbacks of climate change is if you melt off more of the snow and ice, it exposes more of the dark rock or soil underneath it. That absorbs more solar radiation. The planet heats up even more, and you get this positive feedback loop that people worry about. Snow is also very important as an insulator. It's one of the reasons why you can build structures out of it. It's why indigenous populations that live in very, very far northern climates can make dwellings out of it, in part because it does contain so much air. So it winds up being very, very useful as an insulator. And one of the other climate change consequences is if you have less snow on the ground during the winter, or less snow on the surface of a lake or river that's frozen during the winter, you also tend to lose more heat out of the soil. And if you've got, for example, dormant seeds, hibernating animals, things like that that rely on the insulation, they have more problems when you have less snow to help insulate them during the winter. It also regulates, ice in particular, regulates heat and gas exchange between water bodies in the atmosphere. So this is actually important from the standpoint of gases that could escape into the atmosphere, or, for example, if you have carbon dioxide that would normally come out of the atmosphere and go into a body of water, if that body of water is covered by ice, it can't go in, it gets retained in the atmosphere. And of course, in California, we are very aware of the role of snow and ice for water storage. There are websites, if you're interested in knowing exactly how much snow and ice is up in the Sierra Nevadas right now, there are websites you can go to look at it. When we get these atmospheric rivers that drop water near the coast, they also create a lot of snow and ice. That accumulates, and when it melts off during the summer, it supports obviously a lot of commercial agriculture in California, but also helps to refill our reservoirs for human water use. One of the things, so this is a photograph I took a few years ago in the Antarctic, and one of the things you can see about this is sections, this is an iceberg, but this is how some glaciers look from the side. And you'll see that there are these alternate bands of white and blue. You can find photographs online of icebergs or pieces of glaciers that are completely blue like this. This is the color that you get when you have snow and ice that gets compressed to the point where there are no more air bubbles, no more inclusions, and then solid water looks very much like liquid water. It's that same shade of blue, and for sort of similar reasons. This is what happens when you get sort of bands of compression, non-compression, compression. And the nice thing is you can imagine that each of those represents a particular point in time, and you've got this sort of layer cake of different layers of accumulation where the snow fell, and some of it got melted and recompressed, and some of it didn't. Really, really blue ice tends to look like that. And that's partially from the water, but that's also partially the extreme purity of the ice. Not much in the way of contamination, and no ice bubbles, or only very small ice bubbles. I mentioned earlier that you have these these bubbles that occur even in ice, and what that means is that ice actually preserves information about Earth's past climate. So you can drill down through glaciers or through ice sheets, and the air bubbles and the particles that are preserved in those glaciers and ice sheets reflect a record of Earth's past climate and of past events of various kinds. Ice cores have been drilled to a depth of 3,000 meters, 3 kilometers, so that's almost 2 miles. And an ice core that's pulled out can look something like this. There are ice core repositories in several parts of the world. The Greenland ice sheet is not quite as thick as the Antarctic ice sheet, so the Antarctic ice sheet in the deepest cores gives us a record of Earth's past climate going back 800,000 years. Very, very useful information. And this is, I'm not going to go over this in detail, but this in the lower right is a time series from the British Antarctic Survey showing, let's focus on the top panel for a second. It shows past fluctuations in atmospheric carbon dioxide. So if you're one of the people who looks at our current concentrations of atmospheric carbon dioxide, which is way up here, and you look at the record based on ice cores for the last 800,000 years, you will see that our current atmospheric concentrations of carbon dioxide are way above anything that the Earth has experienced any time in the last 800 millennia. And we know this information from a variety of sources, but ice cores are a really, really great source of that kind of information. If you want to talk later about how you drill a 2-mile ice core, we can talk about that. So that's a little bit about snow and ice. Just a little bit about glaciers. There are on Earth over 200,000 distinct glaciers. I've not counted them all, but I believe that you can get that information. And again, they form in the way that I mentioned before. Snow falls, it accumulates, it melts, it refreezes. And one of the interesting things about glaciers in situations like this is they're very, very heavy once they get thick. And the pressure, all of that pressure of all the ice weighing down on the portion of the glacier that's in contact with the ground causes the base of the glacier to melt. It's the same basic physical principle that operates when you go ice skating. If you go ice skating, you're actually skating on a layer of water, not on a layer of, it's not metal on ice. If you try to go metal on ice, you will fall over. It's the little layer of water that keeps it going. And so this water at the base of the glacier provides a lubricant, essentially, for the glacier to flow downhill. But one of the interesting things that happens is glaciers are not solid blocks of ice moving like this downhill. The base of the glacier is in contact with the rock, and so there's friction there. So it drags against the glacier. The top part of the glacier has a lot of weight, and so the overall glacier is moving like this. Think of it as very, very cold honey or molasses flowing downhill. So over time, glaciers don't slide, they actually flow. Material gets essentially eroded off of the channel that they move through and circulated up into the glacier. The top of the glacier cracks. So out of curiosity, how many of you have stood on top of a glacier? Wow, that's amazing. Were there signs or flags or something like that that said, it's okay to be here, but don't be over there? That's because there are these cracks and crevasses in the glacier, and if you step into one of those, well, you wouldn't have raised your hand just now. One of the important things about these, and I'll get to this a little bit later, is they actually transport some of this debris that gets eroded off the land into the base of the glacier, and when the glacier melts, or when icebergs come off the bottom of an Arctic or Antarctic glacier, that terrestrial material gets transported out into the ocean. That can have some very important biological impacts. Glaciers are very important for a number of reasons. There are major rivers like the Ganges River, for example, that starts off as a glacial field. And one of the big concerns, as many of you may know, the Ganges River is considered sacred. One of the big concerns about the Ganges in particular is it's fed by a glacier. That glacier is shrinking and is a result of climate change. And so the concern is that if those glaciers are shrinking or they're melting less, that the flow of the Ganges may actually be restricted over time. There are other issues with the Ganges as well, but that's a source issue. So here's an example just to show you, if you haven't stood near the base of a glacier, this is Perito Moreno Glacier in Argentina, the other A place. And you can see a couple of things. You can see how fractured the top of the glacier is. It's a beautiful setting, absolutely spectacular setting, not my photograph, unfortunately. And you can also see all of the fragments of ice that are down in the water below the base of the glacier, where pieces of the glacier are breaking off and where the meltwater is forming this pool here. As I mentioned before, glaciers are known to be retreating as a result of climate change. Here are a few specific examples of then and now. So this, for example, is Saskatchewan Glacier, which ironically is located in Alberta. So this is Saskatchewan Glacier photographed in 1924, 1985, and 2011, and you can see how far that huge ice tongue has receded. I grant you this is 90 years, but it's still an enormous amount of ice that's no longer there. Similarly for glaciers in other places like the Alps in Austria and Switzerland. Essentially, if you have a very, very large glacier, larger than about 50,000 square kilometers, so 20,000 square miles more or less, that's what's called an ice sheet. And I mentioned before that there are two major ice sheets. There's the Antarctic ice sheet and the Greenland ice sheet. Rather than flowing downhill like a glacier, because downhill is a little bit funny, they actually flow outward from the center. So the central part of the ice sheet is higher, the peripheral parts of the ice sheet are lower, and the ice sheet flows downward in this direction. They melt in a number of different ways. They melt from the top, and you can actually have meltwater ponds in the top of the ice sheet that will refreeze during the winter, that melt during the summer and freeze during the winter. There is the same pressure on the land that leads to melting on the bottom. And actually a large chunk of Antarctic research right now is dedicated to trying to understand how fast some of these ice sheets are flowing in relation to the magnitude of that melting and the motion of the ice. Once they get farther down, so both of these are of course surrounded by water, Antarctica and Greenland, and once they get down to the water, they actually flow out as what's called a floating ice shelf, and there's water underneath, and you have a second source of melting, which is warmer, only slightly warmer seawater that flows underneath and starts to erode the glacier or from below, erode the ice sheet from below, And there's a location right here where the ice meets the ground or the ice meets the seafloor. It's called the grounding line. So a number of years ago, 2011 as I recall, there was a team that was trying to study the grounding line in two different locations. So here's Antarctica in the upper left. I apologize to you guys, the angle's horrible. Antarctica's here. This is the area not too far from McMurdo Station, which is one of the 3 US bases in the Antarctic right here. And they went out, actually trudged out with some snowmobiles, out to these 2 locations, and they used a tool called ANDRILL, which is a really not very good acronym for Antarctic drill. It's a hot water drill. The great thing about drilling through ice is you don't have to use an auger. You can simply pump hot water through some pipes, and the hot water will melt its way down through the ice. So they used an ice drill to drill down here to try to study the grounding line. This is an area where the ice shelf is about 240 meters thick, so about 800 feet thick. And then there's about another 140 feet of seawater below that. And then they used this, how to describe this, it's called SCINI, S-C-I-N-I. It's an acronym, it's a remotely operated vehicle with some propellers and a camera on the end. And they dropped it down, it was designed to go through a borehole. So they dropped it down through the borehole, started looking around, and what they found, living in the underside of the ice, 800 feet below the top, were sea anemones with their bases in little cups that had, I don't know how the cups formed, we're still not sure about this, that had actually melted into the ice. So, or melted through the ice. And you have this whole field of these sea anemones living in a completely lightless environment underneath ice shelves. Never been observed in this kind of setting before. Since then, it turns out that the same species exists in other ice shelf settings underneath, around the Antarctic, but nobody expected to find these animals living actually with their feet in the, in the ice underneath this ice shelf. Truly an inhospitable, to humans at least, environment, but it shows that life is remarkable. It can live in all sorts of interesting settings. This is actually, just to give you a visual, this is a photograph of what's called the WAIS, is the West Antarctic Ice Sheet, just to give you a sense of how this looks. And this is an enormous glacier with some icebergs, sea ice around it, going into the Bellingshausen Sea. I just absolutely love the panorama. I love the landscape. I would hate to have to get from point A to point B anywhere in here, but it is truly a magnificent, magnificent setting. One of the things that people are very concerned about currently has to do with mass balance for the Greenland ice sheet and the Antarctic ice sheet. So this is a paper that was published a few years ago by a group at Scripps Institution of Oceanography based on satellite data. And it turns out one of the things that's very interesting that happens with climate change is you wind up with more moisture in the atmosphere. And because there's more moisture in the atmosphere, you actually get, in some places, more rainfall and more snowfall. And even though the planet is warmer and there are some parts of the ice sheet that are melting, there are other parts of the ice sheet that are actually getting thicker because there's more snowfall. So it turns out that Greenland, there's a lot of, the red is areas where the ice sheet is shrinking, and the blue represents areas where the ice sheet is accumulating. And it turns out that a lot of the West Antarctic ice sheet is actually shrinking quite a bit. So you can see over here the Amundsen Sea. The Bellingshausen Sea, that photograph I just showed you, was taken right over here and up into the Antarctic Peninsula region. But in other parts, like the Ross Sea and other parts of East Antarctica, and I'll let you puzzle over how you set east and west in a place on the bottom of the globe that is radially symmetrical. The East Antarctic ice sheet is actually getting thicker. The net balance is toward negative, so there's actually more ice getting lost collectively around the Antarctic, but it's not a one-way street. And similarly in Greenland, there are parts of the ice sheet that are actually getting thicker, even while other parts of the ice sheet, especially around the perimeter, are getting thinner. One of the things that happens when you get melting is icebergs get produced. And icebergs are fairly straightforward. There's floating chunks of ice. Roughly 90% of an iceberg is underwater. They break off from ice shelves. They break off from glaciers. I think for the sake of time, there's a link to a video there, but I probably will skip over it. If you want to see a video of icebergs calving off, we can do that later sometime. And they come in a wide variety of sizes and shapes. So a little bit about my personal journey in the Antarctic. When I first went to the Antarctic in 1992, I was told, this is back when there were cameras that had this weird stuff in them called film. And so I brought a whole bunch of film. And I was told, you are going to come back with 100 pictures of icebergs. And I said, why? Why would I come back with 100 pictures of icebergs? They said, trust me, you will come back with 100 pictures of icebergs. So we go to the Antarctic, we're on the ship, blah, blah, blah. Spot the first iceberg. Oh, got to take a picture. First iceberg, got to take a picture of that. Not sure my camera, okay, I'll take 2 or 3 pictures of it just to make sure. Then you see the next iceberg. Well, that looks totally different from the first iceberg, so I need to take a picture of that. Came back with 150 pictures of icebergs. And some of it is because they look really, they're spectacular, they're very artistic. Here are just a few examples of different shapes and textures and colors and patterns. And the beautiful thing is now with digital cameras, you can come back with 1,000 pictures of icebergs, and it only takes up a little bit of space on a memory card. You'll see icebergs that have all sorts of odd features like this. These are these very, very clear areas on an otherwise mostly snowy iceberg. You'll see icebergs like the one in the upper left. That actually, I'm just going to tell a brief story. What happens when you have an iceberg is 90% is underwater, 10% is above water. Waves come in, they crash along the sides. It erodes the portion of the iceberg that's above water only. And the portion that's below water you might even accrete a little bit by freezing of some of the water around it, but it doesn't erode because it's not being impacted by the waves. So what happens eventually, again, if you can see the one in the top left, you'll see that it looks like it's kind of tipped on its side. What happens eventually is that enough of the iceberg that's above water erodes away that the whole balance of the ice shifts, and then it rolls, and something that used to be that nice, smooth, sort of eroded shelf that used to be below water is now sticking up like this. And so that also is the case with that iceberg in the lower left. You can sort of see it used to be kind of a flat iceberg. It's got this part right here that is nice and smooth and used to be underwater, and now because the upper portion has eroded away, now it's sticking up like this. So they come in a variety of shapes and sizes. This is the sort of canonical tabular iceberg, and those are relatively common because it's basically a piece of ice shelf that has just broken off and floated away. Nothing special about the shape. It was flat on top before, and it hasn't really eroded too much yet. The U.S. actually has had a system since the late 1970s for identifying and tracking icebergs. I mention this because I'm going to refer to it in a minute. And what they do is they name icebergs, any iceberg that's more than a certain size, more than 10 nautical miles in largest dimension, they put a label on it. So if it originates up here in this quadrant, it starts with a capital A, and then the number is whatever, let's say it's the 75th iceberg that broke off. It's bigger than 10 nautical miles from quadrant A, it's A75. Similarly for B, C, and D. So for example, the biggest iceberg in the world right now is something called A23A. It was the 23rd iceberg to break off from that quadrant up there, and the lowercase a at the end means it is the first fragment. So if A23A breaks into A23 breaks into 2 fragments, you then have A23A and A23B. And they name them accordingly. And they keep naming them as long as the fragments are big enough to merit a number. And because of circulation around the Antarctic continent, which goes like this, basically, the ocean circulates like this, a lot of the icebergs that break off, no matter where they break off, wind up making their way around the continent one way or another. And then they wind up coming here through the Weddell Sea, and you'll see this big concentration that go out right here through an area that people call Iceberg Alley. And if you're looking for icebergs, that would be a good place to start, because that's where a lot of them wind up going. So one of the icebergs that we studied on some of the cruises that I was involved in is this thing right here called A43K. So what is K? The 11th fragment? Something like that? Somebody who's good with letters. So A43K, when we were studying it, this iceberg was around 22 miles long, about 10 miles wide, and the distance from the waterline to the top of the iceberg is about 130 feet. And 90% of it's underwater, just as a reminder. Massive thing, really, really cool to get close to, but you don't want to get too close because you guys all saw Titanic, right? Okay, just a reminder. Beautiful textures, though, really, really amazing. And again, you could take 100 photographs of just this iceberg. One of the things that icebergs turn out to be useful for, if you're an animal that lives in the Antarctic, is they're a useful place to hang out. So can everybody see the black spots on the top of this iceberg? Again, you'll see that this is an iceberg that's tipped up a little bit, right? And if you go closely up there, which I couldn't do, but if you go close to another one that looks sort of similar, you find that those are birds. They're called either Cape petrels or Cape pigeons. It's a beautiful bird, black and white, about this big across when the wings are fully spread. And what they will do is, if they're not flying or sitting on the water, they will sit on one of these icebergs and just drift around. There are a number of animals that spend their time out on the ice, and they do this because in the Antarctic, essentially all of the predators, with one little exception, are in the ocean, which means that if you're hauled out on an iceberg or sitting on land somewhere, there are no predators. It's why, if you're a human being working in the Antarctic, penguins and seals will go right up to you and look at you from just a couple feet away. They have no fear of land predators because they're not used to land predators. So I said before, the world's largest iceberg, there have been lots of news stories about this A23A. It is, depending on who you are and what you like to compare it to, it is roughly 2.5 times the size of Greater London, which is about 3 times the size of New York City. So it's 4,000. It was originally 4,000 square kilometers. Hawaii, the Big Island, is about 10,000 square kilometers, so it's a substantial percentage of that. And the cool thing about A23A is it broke off from here, the Filchner Ice Shelf, in 1986. And then it got stuck. And it stayed there till 2023. Frozen, not moving. In 2023, it finally melted out enough to move. You can see a satellite image of it right here. And it's now drifting up and has now moved beyond the tip of the Antarctic Peninsula. The concern was that it might actually get up into shipping lanes up here and do some real damage. But it seems like it's going to just melt and melt and melt and melt and eventually fragment into lots of small pieces and disappear. And that's the fate of an iceberg, basically. Some people have thought about doing creative things with icebergs. So again, for those of you on this side of the room, this is an iceberg with 3 US Navy ships pushing it. This is against every safety manual that has ever been written for how you operate around icebergs. And so this was in the mid-1960s, and what they were trying to do was to clear that iceberg away from shipping lanes so that you could get into McMurdo Station, which was this US base. But it's sort of an interesting idea because actually, I've told you before how much water some of these things can contain. There have been discussions at various points in time, mainly from Middle Eastern countries, about taking an iceberg from the Antarctic, hooking it up to 1 or 2 large ships and dragging it up to someplace close to Saudi Arabia, and then being able to harvest the fresh water as it eventually melts. Seems like a lot of work. So eventually they've decided that commercial desalination plants were an easier option, and they've gone that direction. But this is something that was discussed. Really, really, really not safe from the standpoint of like being in the ship. I'll finish off with a little bit about sea ice. Sea ice is basically ice that forms over the ocean. Sometimes you have multi-year ice, like that beautiful illustration you showed with the ice field crushing the ship. There are photographs that look remarkably like that maybe I'll show later in the semester. So ice forms typically during the winter. It starts off as these small crystals that are called frazzle, and eventually these small crystals clump together. Initially they form something that's called grease ice, which literally looks like oil floating on the surface of the water, even though it is ice. You sometimes get nilus, that is essentially big smooth sheets of ice, but eventually, and I'll show you some pictures of this, you can get pancake ice or brash ice. That's what you see in the upper right here is more like brash ice. And I'll talk a little bit about what some of this sea ice does, and that'll wrap me up. So in the top left, we have what's called pancake ice, for, I hope, obvious reasons. Pancake ice forms when you have little bits of grease ice that start to clump together, and they form these little floating areas, and they start banging into each other. When they bang into each other, it pushes the edges up. And as they keep freezing, they keep getting bigger and bigger, and they keep banging against each other, and the edges keep getting pushed up. So you get this wonderful pancake ice. This down here is this sort of loose collection of different kinds of materials. These are what people sometimes call either growlers or bergy bits, basically little fragments of ice. with some sort of slushy ice in between. And I don't know if this will work, but if it does, you'll see